By the end of this lesson, the students will be able to explain the principles of fractional distillation as a method of separating the liquid components of an ideal solution, state the industrial uses of fractional distillation. Fractional distillation is used to separate components of a mixture of liquids by means of the difference in their boiling points. The distillation flask above contains an ideal mixture of methanol and water. Click Apparatus and select each of the apparatus one by one. Click on the burner to start the distillation process. The processes taking place in a fractionating column can be understood using a column that contains bubble caps. Click on the fractionating column for a larger view of these caps. What are the processes that are taking place within the column? Answer: vaporization and condensation. In the laboratory, the fractionating column is filled with glass beads instead. What is the purpose of the glass beads? Answer: to provide a large surface area for condensation and vaporization to take place effectively. Why is a longer fractionating column preferred? Answer: a longer fractionating column is preferred as it enables us to achieve a better separation of the components in the mixture. Click the temperature button. How does the temperature change going up the column? Answer: the temperature decreases going up the column. The lower part of the column is hotter than the upper part. Let us investigate how a mixture of water and methanol is separated by fractional distillation. Click on 20 to view what happens when a mixture of 20% methanol is heated. The mixture boils at 90 degrees Celsius. Click on 90. The vapor produced has a composition of 35% methanol. The vapor condenses on the beads in the lower portion of the column to form a liquid with the same composition. This condensed liquid trickles down the column. As it meets the ascending vapor, it gets heated. Click 35. The condensed liquid boils at a temperature of 83 degrees Celsius. Click 83. The composition of the vapor produced from the condensed liquid is now 58% methanol. Click 58. Repeated vaporization and condensation leads to a vapor that gets richer in methanol. As time goes on, the beads gradually heat up, allowing the vapor to move upwards slowly. The vapor that rises to the top of the column is then condensed and collected in a receiving flask as a distillate. What is the composition of the distillate? Answer: the distillate is pure methanol. What is the residue in the distillation flask? Answer: water. Summary: fractional distillation separates the components of a mixture according to their boiling points. The fractionating column containing glass beads has a large surface area so that the ascending vapor and descending liquid can have maximum contact. A longer fractionating column enables a better separation of the components in the mixture. The temperature drops as the vapor ascends a fractionating column. By repeated vaporization and condensation, the vapor becomes richer in the more volatile component, whereas the liquid in the distillation flask becomes richer in the less volatile component. Fractional distillation is also an important technique used in industry. The petroleum industry, for example, uses fractional distillation on a large scale to separate the components of crude oil. Crude oil is vaporized and fed into a fractionating column as shown. Click on each of the tabs of the column to view the fraction that is drawn off at different levels of the column. Click the Uses button next to each box if you wish to find out the uses of each fraction. Fractional distillation is also used to obtain nitrogen gas for industrial use. Approximately 78% of the air consists of nitrogen gas. Suggest how this is done. Answer: air is first cooled until it liquefies. Nitrogen is obtained by fractional distillation of the liquefied air. Summary: petroleum refining and obtaining nitrogen gas from liquefied air are some examples of industrial uses of fractional distillation.